Hi everyone, welcome for today's session. Today we are going to see the fourth day of our session. So we started with Thursday, so Thursday, Friday, and we have a Monday and Tuesday, right? We have a Monday and Tuesday. Just a okay, sorry guys. Okay, fine. So yeah, so let me share the screen now. So before that, yeah, so let me open the PowerPoint presentation. Yeah, fine. So we are the fourth day of our data analytics. So yeah, let me create new slide. To write it to my own convenience. Okay, fine. So let me share the screen now. Yeah. Okay, guys. So very first day we discussed about the day one. We discussed about the application of ML on trade analytics. ML on trade analytics. It. That is the first thing we discussed about it. Okay. So let me record. Did I record the session? Yes. Okay. Second day we discussed about the day two. We discussed about day two. We discussed about CRISP MLQ method, cross industry standard procedure for machine learning with quality assurance. So the day two we just deal with machine learning, the CRISP MLQ. Actually, yesterday our plan was day three was EDA and data pre-processing. But we spend more time on EDA. So today we are going to do the fourth day. We are going to take off data pre-processing. Right. So each stage and day five, we will be tomorrow. We're going to discuss about k-means clustering. And day six, we are going to deal with that. Day six, that means day four, day five, day six, day seven. Or day six, yeah, day six, we are going to deal with day six, we are going to deal with yeah, KNN neighbors. KNN neighbors. And eight, we are going to deal with decision tree. Then day nine, we are going to deal with regression technique. Regression technique. Day 10, we are going to do MLP concept, multi-layer perceptron. So this is our agenda of last next overall of session is 410. So now let us, without wasting time, let us quickly go to the data pre-processing. So again, we can have a quickly recap what we discussed. What is data types? Why do we need that? So data types, we have a multiple data types. We have a different kind of data types we have, right? Continuous versus discrete data, structure versus unstructured data, big data versus non-big data, right? Big data versus non-big data, and time series cross-sectional versus time series data, cross-sectional versus time series data, live streaming versus batch data, live streaming versus batch data, and so on. So there are multiple data types, different kind of data types we have. So the success of machine learning, is based on quality of data. Quality, how do you define, how do you access the data? How do you access the data, guys? We can access the data by using, we can assess the data by using EDA, right? So in EDA point of view, we are trying to understand the data, the characteristic of data. So if you are doing some clustering, then you do exploratory data analysis, mean to mean average, then that could be easy. That could be more appropriate. So do data pre-processing. The primary thing is data pre-processing. Because as we know that we are collecting the data from different sources, collect the data from different sources, and it can be a different format. It could be a different format. It could be a different format. So the algorithm, machine learning algorithm should be in a position to accept the format. So the format should be accepted by machine learning algorithm. Right? Okay, fine. So exploratory data analysis, what are they discuss about? Exploratory data analysis, exploratory EDA. Exploratory data analysis. The first thing is we discussed about exploratory first moment business decision. First moment business decision, second moment business decision, third moment and fourth moment business decision. So first moment business decision we talk about mean, median and mode. Second moment business decisions we talk about. Second moment business decision we just talk about variance, standard deviation and range. Second moment. Third moment, we have a skewness of data. Fourth moment business decisions, we talk about kurtosis. This kurtosis. There are four moments of business decisions we come across. So the first moment decisions only talk about center of data. Remaining rest all the three will talk about spread of the data. The rest all the three will talk about spread of the data. Okay, next we have a data pre-processing. So we come to data pre-processing. Why do we need the data pre-processing, guys? What is the requirement of data pre-processing? What is the requirement? The data pre-processing, we are organizing or we are cleaning the data. In data pre-processing, We are organize the data as well as we are clean the data. We are cleaning the data. Got it? We are organize the data or we are clean the data. So the data set, the primary data or the raw data set contain maybe anomalies, missing values, okay, or duplicate value. There are many different the factors contained, right? So this is mandatory to look. This is mandatory to look back or just look the data clean. To make the data clean. Okay, to make the data clean. So when as a pressure, the people who don't have a more experience, they just join as an entry level, right? So they will be in a position to work in the data pre-processing. So 80%, any project, there are 80% of data, 80% of work time we will spend on data pre-processing. Assume that how important is that? Right? How important is that? So data pre-processing, yes, it is crucial factor. And we have a different kind of data pre-processing. We are going to deal with different kind of data pre-processing. So what are the different kind of data pre-processing? One is typecasting. So as I mentioned before, data pre-processing, this is for cross-sectional data. Another is for textual data pre-processing. Textual data pre-processing. So both will be varying from kind of factors which we know. So cross-sectional data, what do you do? In cross-sectional data, we have a rows and columns. It's a fixed set of dimension. That's called, we used to call as data frame. We used to call as a data frame. Just a minute. I'm just logging Python now. Let me. I open my Python now. Yeah. Okay. Let me close this Python. Let me close the file because I opened so many files over here. So let me open this. And we will look at what are the different data pre-processing in Python as well as the concept was. So both we are going to deal with it. Again, I'm running for. Okay, let me close this. Okay, so what are the things we have? Data pre-processing. The first technique is typecasting. So what is typecasting? What is typecasting? So typecasting is nothing but we are converting one data type into other data type. One data type converted into another data types. Another data types. Okay, data types. That means, for example, we have different kind of data. What are the data types we have? Float. Yes, we have an integer or string format. Boolean. There are multiple factors. There are various data types. But what we do now here is so we are going to convert from one data type into another data types. One data type to other data type. What is the necessity of this? See, when you have a, let me show you this. Let me show you in the Python. So let me just a minute. Let me show you this. Just a minute. I'm just taking the Python file. So the folder. Let me force it. Okay. So now we are going to work with some data set. So typecasting. Okay. Yeah. Okay. Typecasting. So typecasting, you're able to see now my screen. So yeah, let me download the file first. Ethnic diversity, right? Okay. So as usual, we are loading the data set. The import pandas are speedy. So we are going to work with typecasting. Okay, so typecasting, I'm reading the data set. In the data set, we have an employee name, position, marital status. So all these different variables we have. Now I just want, we used to have D types. We used to do D types. What is D types? The D type is the inbuilt function in Python. D types is inbuilt function in Python. So when you want to know the type of data, when you want to know the different kind of data types, you can click data.dtypes. You can click data.dtypes. We click this. So you will have the name of that. Employee name, object, employee ID, integer, zip, sex, citizen, salaries, age, race, and there are multiple categories we have. Multiple category data.dtypes. So in this data set or in the data frame, employee ID, zip folder, and employee ID and zip folders, these are nominal data. These all are nominal data, but the nature of data is integer. So what we can do, we can convert into the nominal data. For example, we are converting into the string format. We convert into the string format. So for that, we are using as type. As type is the function. So that helps to convert into numerical, or it will be converted into the non-numerical value or numerical to non-numerical. It is up to you. So what data types we are converting? We want to convert into the string format because it is numerical value, right? But it is meaningful. It's not meaningful. So when you are applying mathematical calculation, this will also get calculation. So it's not required for us. No need to do that. Since it is employee ID. So what you are using, I saved it in separate variable. In the variable, I'm using data dot emp id dot as type and string. Okay, string format. Okay, so data dot emp id dot as type and string format. So this is called, we converted into the string. And when you have a D types, so now it become an object. Object means non-numerical value, string. Okay, so we converted employee ID from integer 64 to object. Now, if you look at that, okay, now what we have to do, zip code also, it is nominal data, right? So we can convert it into nominal data has been converted into string format, the same thing. Data dot zip equal to data dot zip as type function. So when I do this, we can get as a, okay, we can get as an object. So now salary column is float value. What is the float? See, float, integer 64, 32. These all are kind of byte. We used to call as byte. Byte means it's a binary digit. It is whenever whatever you are entered in the numbers or anything. So it is OS based, the OS system based. So it will take occupying the 64 or 34 bit, 32 or 64 byte. And type data dot age dot as type and convert it into the float value, float 32. So we can convert into the float 32. So D types. So yeah, so what we do, salary integer and we convert to the integer. So when I look at my salaries column become an integer 64. Next, age. So age I want to convert into the float value. So this is about. So the data, the typecasting is nothing but we are converting one data type into our desired data types. Desired data types. That's called typecasting. We used to call us typecasting. Okay, fine. The next thing is what we are having is handling duplicate value. What is that handling duplicate value? So handling duplicate values are another important scenario. Handling duplicate value. What is handling duplicate values, guys? So when you have a data set, let's assume that there is a bank data set. Okay, let's assume there is a bank data set. So the customer is defaulter or not defaulter? The customer is going to be a defaulter or not defaulter? So when you're having age, gender, and transaction, all these things happen, right? All the variable. So let's take 45 years age. Gender means male or female. Okay. And we have a transaction amount and something. So when you have the same value, if you have received the same value in another rows, 40 years male transaction, let me clear something. Age, gender, transaction amount, and we have a EMI amount, then it's a defaulter. Defaulter or not defaulter? Let's assume this. So the row 50, let's assume row 50, 35 years old, male, transaction amount 50,000, EMI 5,000. He is a defaulter. So in 10th row, same 35, male, 50,000, 5,000, and 0. And 35th row, 35, male, 50,000, 5,000, and 0. Let's assume this is everything. So when you have a same records multiple times, this is called redundant information. This is called redundant information or repeated information. Okay. So our machine learning have intelligence to remember the problem. So no need to repeat it. If in case if the values are keep increasing, right? Or the same value has been keep repeating, that means only the computations will get increased, but information should be the same. Information remain the same, but only the computation is getting increased. So we don't want these kind of things. So we can remove the duplicate value. So it will foster my activities, right? If I remove the duplicate, so my computation will be speed, right? The activity, the speed, the process should be improved. So efficiency it is increasing. Right? So better we can avoid that. Better we can ignore the row, repeated row. That means duplicate rows. So that's what handling duplicate value. We can say it's a handling duplicate values. So how do we do that? What function we use? Yes, we can look at by using Python. So we have a call. The function is called. So let me load duplicate data set. Which contain duplicate data sets. So let me take this. We go to here, data preprocessing. Okay, so I'm copying this. Okay, now the data become a core data set. So what do? We have used the function called duplicated function. The function name called duplicated. When you do duplicated, data dot duplicated. Data means my data set, and I am using my duplicated function. So if I use duplicated, whatever value get duplicated, it will show mark as a true. If mark as a true, for example, it mark as a true. So whatever unique value, it will be mentioned as the false. Okay, so true or false. That's what we are going to look into that. So here we have data dot duplicated. Data dot duplicated. Data dot duplicated function. So, okay, now we want to know how many duplicate value are present in my data set. So we have a summation, sum of duplicate. When you have a sum of duplicate, then it will show you the total number of duplicates. So in my data set, out of 32 rows, I have 3 rows are duplicated value. So I have a parameters. For duplicated functions, we have a parameter. One parameter is keep equal to lost, keep equal to false. So what is happening keep equal to lost? Let me tell you. See, when you have a keep equal to lost, that means the last word will be considered as a unique value. The first value is considered as duplicate value. See, let's assume there are first row, second row, third row, fourth row, and fifth row. Like that, we have 20 rows. Let's assume this. So row number 2 and row number 5 are row number 19. All are duplicate, same row. If I make default value, what happened? This is considered as a false. This considered as a true. This true value is considered as true means it's a duplicate record. We would identify it's a duplicate record. So when you have a default method, the first value, the duplicate of the first value is considered as a false. Rest all two will be considered as a true. That means remaining two are duplicate records. Fine. Just a minute, guys. Just a minute. Just a minute. My bad. So where we are, yeah. So when you have a keep equal to lost, then every value, first value considered as a false, that means its unique value remaining all considered as a duplicate default method. But when you keep equal to lost, when you say keep, there are three values 20, 25, 30. So all value considered as a duplicate value, that means true, true. Only one value is considered as a false. So this is unique value. The last value is unique value. That's what keep equal to last. But there are three rows, they all are same. If you keep equal to false, everything will be duplicated. False, false, false. All the values are marked as a duplicate value. So that means we can identify three all our rows duplicate value. So that is what we observe that. Okay, now. So when come to now, how do we handle the duplicate? Duplicate we can by using removal of the data. Just a minute. Okay, guys. So okay. So duplicate value you keep equal to false. So how do we do that? I can remove by using drop function, drop underscore duplicates. If I use this, I can able to remove the duplicate value. So drop underscore duplicate data dot drop underscore duplicates. If you use this function, automatically your the duplicate value has been removed, can be deleted. Okay, this is about a row. What about column, guys? See, row means when you have a row, the value should be the same. But when come to column, it's not required to be value should be the same. Instead, we have another technique called correlation. Okay, we have another method called correlation. So correlation will capture the same information. I mean, when which variable having or what are the variables having correlation? That means if x value is increasing, y value is also increasing. X value is increasing, if y is also increasing, that means it is correlation. We already discussed about in the EDA part, right? For bivariate analysis, we have a two things, two variables. When you have two variables, there are three things we need to look into that. One is called three factor we need to look into that. One is consistency or linear. Second, direction. Third, we have a strength of the data. So we can quantify the relationship by using correlation waves. That correlation we can able to find by using the data dot CORR function. Correlation coefficient function. Okay, so yeah. So I'm using this data set is called core D3CSV. And I'm finding correlation value for that matter of fact. So here what you're looking HP. So both are same variable. So same variable correlation is 1. So the variable -1 to +1. The correlation, the range is -1 to +1. So HP and SCP having a more correlation, 97% correlation. Or else weight and volume. Weight and well, if you look at the data, you will look at this. Weight and volume 89, 82. If it is increasing, if weight and volume, if it is increasing, this is also getting increased. Same value, same value, same. It suddenly is reducing, increasing, suddenly reducing. Correct. So if the data is, if they have a correlation, that means they'll be able to find the relationship. It can keep increasing or it keep decreasing. That's what about correlation method. Okay. Third thing, we have an outlier treatment. We have an outlier treatment. What is outlier treatment, guys? First of all, what is outlier we understood? So outlier is nothing but the abnormal value, or we would say extreme value. So abnormal value or extreme value, the value which influencing the mean. The value which is influencing the mean or average. So that is called outlier. So how do we find outlier? So outlier by using box plot. We all know what is box plot, correct? What is box plot? The box plot means this is lower limit and upper limit. This is 75 percentile quantile, 75 quantile, 50 quantile, 50th quantile, or 25th quantile. The overall is called, this is called IQR, interquartile range. So interquartile range can be calculated by IQR equal to Q2, Q3 minus Q1. Okay, Q3 minus Q1. So that is called median value. This value is called median value. Okay, so below the line, below upper limit, there are 100% of data. So below the line, we have 100% of data. So whatever value come after above the lower limit, as well as below the above the upper limit and below the lower limit, it is called as outlier. This is called outlier. box plot, by using box plot, we will be able to look, right? Okay, we will look at the project. Okay, fine. So box plot we understood, right? So box plot. Okay, fine. Now, how do we do that? How do we find the first of all? What is required for that to identify this? What do we need? What we need it? First, we are loading all necessary package. Let me clear all so that you will not get confused. So let me load all necessary package over here. Outlet pandas SPD, numpy np, cbon as a essence. So when you do pd.read underscore csv, I'm reading this. And we are looking for box plot. So sns.boxplot, df.salaries. If you look at this, I used to get plot value. So there is an outlier, right? In salaries column, I have an outlier. But in age column, I don't have outlier. So now we have to detecting the outlier by using the limit. First of all, we need to find the limit of that. So limit can be lower limit as well as upper limit. Limit is called as lower limit and upper limit. So in order to find the IQR, we used df dot salaries, df salaries dot quantile. Quantile means inbuilt function in IQR in box in the Python quantile. Quantile is inbuilt function. Okay, so we need 75. 75 means Q3, right? What is the value of Q? Q1, Q2, Q3. This is median. So in order to find the median, we need to use IQR equal to Q3 minus Q1. Q3 minus Q1. Okay. So when you do that, when you print, you will get IQR number. For example, if I look at here, okay, I'm just doing this IQR. Print IQR. So my IQR number is 28,359. What about lower limit? So if you print lower limit, you can get the print lower limit. So 19 minus 19,4406. So let me tell you print about the upper limit. So here the upper limit is 90,992. So now what do you do here? We need to find outliers. So in order to mention, I create new variable called outlier underscore df. Okay, outlier underscore df. There is a new one. So here we using np.var function. np.var function. So np.var function will look the condition. So np.var function is looking the conditions. Conditions is df dot salaries. If any value above upper limit, you can mention as a true. Okay, any value above true, if above upper limit is called true, or else you can mention as a false. Here, any value np dot var, any value is mentioned as a true. Okay, that's also considered as true, or else you can keep it false as it is. Okay, done. So now I am using some complementary function of, for example, df dot location. I want the location of outlier underscore df. So whatever value is outlier, I don't want that. Outlier means true false. Okay, so which is not all rows and all columns. It's talking about it. So now I have a trimmed data set. So it contains only the trimmed data sets. It's contain only the trimmed data set. Look at data one, it will show you the data one is for I location, ILS location. So now this is one of the trimming technique to remove of technique. But when come to replace technique, we have a different kind of things. For example, replaced. So if any value above upper limit, you can mention upper limit. Any value lower limit, it can be lower limit. Same thing. So that is a things. Third thing, we have a winsorization technique. When you come to winsorization, it's third-party package. It's the third-party package. So we install pip install feature underscore engine. So this function feature underscore engine. From that, we are using winsorizer function. So feature underscore engine dot outlier. From the outlier, we are input winsorizer function. So winsorizer functions only that we have different type. One is IQR, the parameter capping method. Capping method is IQR and capping method is Gaussian. And another capping method is for font type. So there are multiple various things we have looked into that. So fine, it's a tail, both 1.5 and salaries. So fit underscore transform. Whenever you are using third-party functions, you can use fit underscore transforms, but we need to use it. So next we have a zero variance and new variance. See, assume that you have a data set. In your data set, you have an age column. If you have a same age of number, it is called constant. That means zero variance. There is no information. See, all the value are same in the same column. That means no information. Right? No variation, especially no variation. That's what we can say. No variation. If there is no variation, that means it's constant. So all the value telling the same thing. If the person from the employee details, if the person from all are from America, USA, all the countries you see. So there is no variation happening in the Excel sheet or in the particular data. So that we need to keep it in mind. So for that, we are removing or we are trimming the data or we are replacing the data. So that's what we happen by winsorizer function. And zero variance. Zero variance, yeah. When what we do, we are looking df dot var function. Var function means it will tell you the variance of the data. Variance means more information. It's not similar information, it can be different information. Correct. If we have a similar information, that's fine. You can take a call on it. No need to separate analysis for that. So when I call it df dot variance, you look at this variance of that, each variance, employee 3 is equal to salaries 2. No value is close to 0. Is there anything close to 0? No. So false. So that is the information gain in the data set. Okay. So next we have a discretization function. Discretization. Discretization. What is discretization? The discretization is mainly used to convert numerical into non-numerical value. So numerical to non-numerical. Numerical means there is a salary. Okay, for example, 10,000, 15,000, 19,000, 20,000, 21,000, 23,000, 24,000, 25,000, 26,000. So like that, it keep going. So you want to convert into numerical to non-numerical. Yes, we said that whenever the numerical data only will help you to get more insight. There is no wrong in it. But in some cases, you don't want this value. You don't want numerical value. So instead, you can use it. You can convert it to the non-numerical value. So non-numerical value can be a low, high, or medium. So based on the salary. So you can name appropriate, you can give appropriate name for that. Okay, you can give some appropriate name for this. So that's what discretization is similar to the binning or grouping. We just discussed about histogram, right? We discussed about histogram, the same kind of things. But here with binning, the process is called as discretization. Discretization. Okay, so that thing we understood. When we look into that, okay, so what we need to do here, we have to look import pandas, unloading data. So pandas as P here. So intermediate set and the tail function. Tail function means what? It used to get a last 5, the last row, last 5 row. The default is last 5 row. If you want 5, you can get. If you want 10, you can get the last 10 rows of it. So these are some necessary functions. So when come to binarization, there are binarization and multiplication. When come to binarization, we are loading the function called cut function. This in the PD pandas library. So pd.cut function. Here you have a data and wins. Wins means minimum, maximum, and labels mean low or high. Okay. So salaries dot mean and low or high. So now when come to columns, okay, and we can look out the break of count. That what we have value underscore counts. If you use value underscore counts, you can get the breakup of her. What is the value for 177? What is the value of 133? And when you have a dialog dot mean, you can. This is for multiplication. This is for multiplication of this. So we done it, and we can perform point. So multiple pin, not only one pin. So we can create multiple pin of it. We can give a number or directly you can give, you can define some values. For example, min date salaries. So minimum value it will take and maximum value it will take. So minimum value, mean value, and max value. So previously we have a Yeah, same thing we done it for salaries also. Salary pension. The next we have a called dummy variable ratio. Dummy variable. The process is called dummy variable creation. What is dummy variable creation? See, when your data set contain non-numerical value. So which is most expected? Which is most expected thing? So the non-numerical value, right? Dummy variable creation, the non-numerical value. The numerical value is most preferred data. Non-numerical is not preferred. So because when you have a numerical data, you can perform all mathematical operations. Guys. We can perform all mathematical operation. Okay, when your data is non-numerical, nothing, you can't perform anything about it. So dummy variable creations will convert non-numerical to numerical value or numerical to non-numerical to numerical value. Just a minute. Okay, fine. So in dummy variable creation, what happened here when you have a mode of transport? Let's take mode of transportation. So you have car, bus, van, auto, right? A car, van, bus, auto, and we have a tractor. So when you want to convert into, you can create car, plus you create the same variable. Take unique value and create as a variable. If the value is present, you can put 1. Rest all should be the 0. 0, 1. So van should be. So whatever value present, that value in the column, it should be 1. Number 1 is present. So this will be converted, the unique value converted into the unique column. The value has been converted into the unique column. So what is called? The value is converted to create a column. What are the other things? In dummy variable creations, we have two types. One is called one-hot encoding. Another is label encoder process. One-hot encoding means it's a 0 or 1. In the input, you have only 0 or 1. But when come to label encoding, can be a 1, 2, 3, and 4 like this. So we have a car, bus, van, and auto. Car, bus, van, and auto. So car means it should be a 1. No, there's no variable. You can have a transportation. So car is 1, bus is 2, 3, and 4. So the concerned number, it is for ordinal data. We can use it for ordinal data. You can use it for ordinal data. But when your data is labeled data, you can use it 0 or 1. Zero or 1. That is called dummy variable creation. The next part we have a missing value. Dummy variable creation, how to do that? Yes, we can come to the So dummy creations, let me clear all to avoid confusion. We load pandas as P and numpy as NP. Unpackage. Then I want to drop a column of that. Why does it mean wrong? Okay. Okay. Okay, my bad, this is wrong. So DM dot, this is what just for reference. So get underscore dummies, the function which we use pd dot get underscore dummies. The function we used pd dot get underscore dummies. That means it will get value. Is used to get the value of that. Okay, and we have a column. So O0 encoding, we have a df.columns. So we used sklearn preprocessing from import O0 encoder. Okay, from sklearn preprocessing. We are putting O0 encoder. So let me run the file O0 encoder. Next, I'm defining the function. Okay, you have to define the function, right? So I'm defining the function on then drumlet the DNF dot. So almost done. Yes. So now I have label encoder. So I'm loading label encoder. So instead of taking O0 encoder, we are taking label encoder function. So only the function name is changed. The label encoder. Here I'm using O0 encoder. I'm using label encoder over here. That is the only thing I have changed. So we want to fit into the transform. So fit transform, we make it here. Yes, we run it. So before that, we need to split training as well as test. Then we can split the data. Okay, fine. So now we have a missing value. Okay, so the another stage is missing values. Missing value. What is the missing value? See, when you take a data set, when you are taking some data set, in the data set, any one cell is missing. Any cell is missing. If any one cell is missing, then the complete row will not be considered by the Python. The complete row will not considered by the Python. That is called missing value. So it is getting so single value, single cell should not be empty because algorithm will not take as a empty. My machine learning, my Python algorithm or Python will not consider as a empty. So completely it is get rid. Then what we need to do? We need to use function called invitation. The function called invitation. So invitation means we are replacing the value. So we used to have a replace the value. Here replace the value with mean, median, and mode. See, in missing value, there are three variants, but at the moment we don't, due to the time constraint, we are not covering it. If time permits this, we can look at the three variants of missing values. Three variants of missing values. So we are going to import NumPy, pandas. Okay, when I read that, I'm going to do the pd.read. And how to check the price empty, the particular cell empty. So you can use df.isNA.summation. Okay, df.isNA.summation. So if you are running, yes, you can able to play those. So right, so now it will show you the sum amount of that. What is the summation of that? So sum function, position, state, sexual, marital status. Okay, now we come to the topic of imputer. The function which we are loading here is imputation. So that function comes under the scalar dot, not preprocessing, the scalar dot impute function. So the scalar dot impute function. From the impute function, we are loading simple imputer function, simple imputer. Okay, simple imputer. So let me run the file. So now we have a missing value. Missing value means equal to np.enable. And yes, we are right. So now, after we are applying np.enable, the strategy equal to mean. If you want to replace the empty cell with median, you can put median. So we are converting pd.data frame. Why do we convert pd.data frame? Because we are mean transformation. When you use fit underscore transformation, your data will be in a different format. Look at this data in a different format. So you need to convert it into the data frame so that you can able to perform any things, any mathematical or any statistical things on the particular data. So that is called simple imputer function. So yes, we do that. Mean imputer, median imputer, and mode imputer. So there are another technique called constant value imputer. Constant value imputer. So in constant value imputer, we need to replace the, instead of using mean, median, mode, we can use constant. The word called constant. When you are doing this, missing value np.nan strategy equal to constant and fill value equal to I don't want most frequent or median to replace the value. I want to fill the value of some constant. So I want to fill with the constants. So I used here. So now after bit underscore transform, I'm making to the data frame. So now when come to random imputer, I used a random sample imputer. I do that. I created one and is.na.sum. So random from feature engine dot invitation. So random simple imputer. The remaining all directly we can get from SKLM. But here feature engine we have invitation input random sample imputer. So that's also can learn from random imputer. Next, I have a normal compute plot. So normal QQ plot is normal quantile plot. It's called as quantile plot. So here we are import pandas as PD. Import pandas as PD. So education.csv file. So I'm copying file. I used to have this. Okay, and we have loading from scipy.stats. And we are using prop plot. Prop plot mainly used to data is distributed or not. So prop plot, probability plot. We have distribution plot also, probability and distribution plot. So how do we refer that? How do you come to interpretations? If your data is, if majority of data fallen in the straight line, it is called as majority of data fallen in the straight line. That is called normal distribution. Okay, the majority of data lying in the straight line is called normal distribution. If data is not a straight line method, we used to call as not normal distribution of the data. Not normal distribution of the data, we'll say. So when we do education, and I'm just looking for probability. So transformation, what is transformation first of all? So transformation technique is when your data is not normal, we are converting. So we are transforming from, we are converting into non-normal to normal distribution. So we use some of technique, for example, logarithmic method or exponential method. Okay, logarithmic, exponential, square root. Okay, square root. And we have a box fox. Then we have a yellow Johnson. Okay, Yo Johnson, not yellow Johnson, Yo Johnson. So these are some transformation technique which helps to transform the data from one type to another data types. To guess. So what we need to do, we need to load stats.plot fitted data. So we can use stats.boxfox. We can use stats.boxfox technique. So this is the function. When you use this function, let me tell you. When you use the function, filtered underscore it plot is not defined. Okay. So let me clear all, and again I'm running this. So import pandas as PD. Put pandas as PD. Then I'm importing stats model. So I loaded my data completely now in the format. Now I'm looking for my prop plot. Okay, fine. So now what we do, we need to look at this file. Look at the plot. So data is normally distributed. No, not normal, right? Data is not normal because the majority of data is not in this range. So only limited data is fallen in the range of straight line. So what we do, we need to browse stats.prop plot and work experience education.workx dist equal to stats.norm plot by. So fitted underscore data, fitted underscore lambda, as well as stats.box as education.workx. So this is what we planned that. And we have a subplot. I want to run completely. We have to run completely. So when I run this, you used to get yes. So now, so we can fill this as a red. We can fill this as a red. Now it is better, right? It looks different. So this is the parameter you can give at any parameters. You can give it at any parameters. Doing normal, not normal, shadow to like it is false. Right now, and KDE histogram is true. Let me put. We'll make changes on it. I'll put true. So you will get like this. So this is where you can play around with that. You need to change the value. Okay, and there are three important techniques we have is called as another two techniques: standardization and normalization. So what is standardized? First of all, look at what is normalization. So when you have a multiple variable, so every column have different scale. So every column contain different scale. Scale in sense magnitude, I would say. So every column contain different magnitude. So we want to bring every times we can bring into the same scale. We are normalize the data. That is called normalize it. The name is called normalization. We have a two technique. In the normalization, we can have min max scalar. The technique name is called as min max scalar. So what does min max scalar will do? Take x minus min divided by max minus min. So this is the formula which we are using for normalization. So when you are doing normalization of data, your minimum value will become 0, maximum value will become a 1. So any value will fall in the range of 0 to 1. So let us look at that in normalization function. So ethnic diversity, they look for ethnic diversity, right? Ethnic diversity, we have pasted here. So ethnic diversity, and I'm dropping some column. This is not required. Then we used to give pd._dme, dummies will create a converted numeric value, and we can create a function. The created function is called def functions we are creating. So I run it here, then we can use it. There is another method. We have min-max scalar. So min-max scalar is a third-party package. We're using the function and fit_transfer. So these are the other technique. And apart from that, the final technique we have standardization. So standardization technique means it is also one kind of transformation technique, but here we are transform the data from mu equal to 0, standard deviation equal to 1. So mu equal to 0, standard deviation equal to 1. Right? So we are convert. How do we do that? It will by G value. We have X value. The X value mapping value into Z value. Okay, so they're converted into the Z value. So when you convert to the Z value, it become a mu equal to 0, standard deviation equal to 1. So that will become like this. Just a minute, please. So finally, we do for this, we have a standard scalar method by using third-party package. It's called standard scalar. And we have robust scalar, robust scalar. The robust scalar means when you have data is outlier, then we can use it further. So when your data is outlier, then purpose we can use it for robust scale. So this is about today, guys. We almost spent another 1.5 hours for yesterday, and today we spent for this. So tomorrow we were going to talk about. So let me delete slide. So tomorrow we are going to talk about the clustering topic. Today we have first day we talk about application. Second day third day data EDA code, and today we have a data pre-processing. Right, data pre-processing. So once come tomorrow, we will have another data. So with this, we are stopping now. So yeah, we will meet tomorrow, guys.